this is Tim, and today we're going to do the question number 33rd. It's called the search in the rotated solid array. So basically, he's saying like giving the integer of array numbers sorting ascending order and the integer targets. Suppose numbers is rotating some pivot unknown to you beforehand. Like give you example like 0, 1, 2, 4, 5, 6, 7, and it might gonna be rotated. It's like have like partial solid, right? Partial solid in the ascending order, right? So if if target is found in the array and returns index, otherwise returns -1. So we don't, because it's like pretty obviously. So the most easy way, you just like iterate like the whole array, right, to find if a target's in there or not. But I think that was too easy. Like that was not the purpose. Like I think asking question like that. So you might think a better solution, like so what you conjure in your mind, it's you can do like binary search, right? But people can say like oh, it could be like much more easier, like you can just solve it first. But if you solve it first, that gonna cause like n log n. Like what if like you don't have to solve it, right? Because like we can like use the hint right there as a partial solid. So what do you mean by partial solid? So for example, if I get the number is 7 right there. So 7, if I compare the last one, if it's greater than last one, right? It means this part is not solid, right? So we're gonna look at that part, right? We're gonna compare like if the mix 7, it's greater than the beginning element is 4, which means this left side part is solid, right? So we can do the partial inner binary search right there to check if the targets in the left solid sub array or not. So in the other way, what if like the median is like smaller than the right? It means the right side is solid, right? So we can find it like we can try to find the targets, if targets in it or not, right? So this is the idea. So it give you like log n time complexity. So it give you the constant space. And let's look at the constraint. It says the all the values are unique. So we don't need to like check for duplicate stuff. And let's code it up. So corner case, if nums equal to num and nums so we're gonna return with 1, we return -1. So int left equal to 0, right equal to nums the length -1. So while it's binary search format +1 smaller than right, and you have int mid equal to left plus right minus left divided by 2. And first we're gonna check if we cut it half, if the half position the number is equal to targets, which means we found the answer, right? We just return the mid. So if the nums of the mid is smaller than nums of the right, so we're gonna do this means like I mean like before, this means like we found right, we found like from position mid to the right is solid. So and then after that we wanna find if the target is in it or not, right? So if nums of the mid is smaller than targets, why is smaller, not like equal, like not equal, because the equal is right there, right? We already checked the condition right there. So only possible way in here, it's mid. Well, been confirmed it's a mid. It's smaller than targets, right? And targets is smaller than equal than numbers of the right. So basically we're checking the solution, like the targets in the right side subarray. So if it's in that condition, like we set the left equal to mid, else we set the right equal to mid, right? So what we're gonna do here, like else if nums of mid, which is greater than nums of left. What's that mean? That means like we found from position left to the mid is solid, right? Make sense? In the like example we went through, like I was previous talking about, right? In this case, right, we make it 7, right? So is 7 equal to target? Nah. So we jump to the second if rule. Like if the 7 is smaller than right, now it's obviously like greater than right? 7 greater than 2. And we jump to else if the 7 is greater than 4, yes. Then we find the first, like the left subarray is solid, right? So we want to checking if the solution is in it or not. So and then we do a if nums mid greater than targets and targets is greater than equal than nums left. Then we're gonna let the right equal to mid, else left equal to mid. Okay, so basically we finished the algorithm. At the end, we need to check the left and right. So if the nums, so we just like merge like two, like only left, like two position right now. It's only left and right. So we're gonna check if left is equal to targets. We're gonna return left. So if nums of right equal to targets, we're gonna return right. Okay, else return just -1 if we not found anything. Okay, so submit. Alright. Runs a little bit slow. What happened? My internet sucks. Come on. Okay. Then we jump to the second one, the search in rotate solid array number 2. So since you got the idea from the previous question, right? It pretty much is same question, but right now it has duplicate stuff. Like how can we deal with duplicate stuff, right? So imagine like same idea. If we found the mid, it's equal to the last one. What's that mean? Is that means like you find the whole things, right, between like mid position to the right position, it's all duplicate, right? So we wanna like move the pointer, the right pointer, forward. I mean, no, backward, right? It's right minus minus. Okay, this is the basic idea you need to check. All right, so this is the only things. So let's do it. It's the same idea. So if nums equal to null, or nums the length equal to 0, you're gonna return false. Okay, so int left equal to 0, right equal to nums the length minus 1. So same format, left plus 1, smaller than right. Okay, left plus right minus left divided by 2. So if still the same, like if the arms of mid is equal to target, we still like we're gonna return true. Target, we're gonna return true. And if nums of the mid is equal to nums of the right, which I said before, it means like you find the range of bunch of duplicate stuff. What you want to do, you want to do the right minus minus, right? So, and then you do the else if, and then we do the same stuff we do it before, right? Else if the number of the mid is smaller than nums of right, you mean that you find a right sorted part below, and then you're gonna still need to check like nums. Still need to check the nums of like mid is smaller than target, and then target small equal than nums of right, and then left gonna equal to mid, else right equal to mid, and else if nums of the mid greater than equal than nums of the left. Just be careful. Why here is changing like equal, right? You can check in this condition. You can say like if it's smaller than equal, then and then this one is gonna be greater. Why? Because it might be duplicate, right? It might be duplicate in this condition. Like that's why you need to it might be like duplicate stuff like of the targets in the left solid. For example, it might can be like in the left solid I have like 1 2 3 right, 4 5. So if I target has 3, so I might already find the answer right there. I might find the answer right there, right? So here, so you have to do like greater than equal. So saying if the numbers of the mid is greater than target, and then target small equal to nums of left, we're gonna do right equal to mid, else left equal to mid. Then gonna check the left and right. We don't do this, we just return because it's boolean, we return like nums left equal to targets, or nums of the right targets. That's it. Alright, just submit it. Let me see what's wrong. Expect true, so we found the answer. Let's check it out where I did wrong. Let's change the test case. I guess it's like 2 3 2 5 1. So target's 1. Yes, that was get me wrong. Let me check it out where I did wrong. So if yes, that was right. Oh, I forgot to close out now. Let me change this while this light. Let me see. Right equal to meat. Yes, minus. Else if the nums of meat smaller than nums right, meat smaller than targets, and targets small and equal to nums of right, left equal to meat. Okay. Also if meat greater equal than left, so numbers left and small and equal than targets. That was wrong right there. So that was nums of the left smaller equal than targets. Yeah, I found why. That's it. Alright, submit. Okay, pass. So the runtime is still gonna be log n, right? Log n is just like binary search. We're not using any actual space, so it's constant space, so 1. And thank you so much for watching. Hope this gonna help you guys understand the question. Alright, see you next time. Bye bye.